Good morning, Dr. Tan. We are from Group 1. My name is JINGTONG and my metric number is A23A2098. I'm going to present the introduction of this study. Statistical analysis is a process of examining quantitative data to identify patterns, relationships, and trends. It allows the researchers to summarize collected data, test hypotheses, and make predictions about a population based on the sample data. Descriptive statistics is one of the statistics that's used to summarize, organize, and present the collected data in a clear and understandable manner. The data set that used in this study contains the information that related to individuals' insurance charges and several factors that may influence them. The variables included in this study are age, gender, BMI, which is body mass index, smoker status, region, and life insurance charges. Age, BMI, and insurance charges are numerical variables, while gender, smoker status, and region are categorical variables. The age represents the respondent's age. BMI measures the body weight relative to height. Smoker status identifies whether the respondent is a smoker or non-smoker. Region refers to the respondent's residential area, and life insurance charges represent the annual insurance expenses. Statistical data analysis is beneficial for this dataset because it enables researchers to identify the characteristics of respondents and examine the factors that may influence life insurance charges. Furthermore, inferential statistical techniques such as the independent sample t-test and one-way ANOVA are used to determine whether significant differences in insurance charges exist among different groups. Therefore, statistical analysis help to identify the relationships between the variables and support evidence-based decision-making.
Good morning, Dr. Tan. My name is Tan Jing and my machine number is A23A2075. I will explain the sampling and data selection process used in this study. So before conducting the statistical analysis, we were required to select a sample from the original insurance dataset according to the assignment instructions. First, we listed the metric number of all group members and extracted the last two digits, which were 75, 7, 32, 53, and 98. From these numbers, the smallest value was 7 and the largest value was 98. Based on the given formula, the sample size was calculated as 500 minus 7, which resulted in 493 cases. The number of cases considered for sampling was calculated as 500 plus 98, giving 598 cases. By using SPSS, we selected exactly 493 cases from the first 598 cases through the random sample of cases function. After that, the unselected cases were deleted, resulting in a final dataset containing 493 observations. The sampling method used was simple random sampling, where every observation among the first 598 cases had an equal chance of being selected. This method helps reduce sampling bias and improves the representativeness and reliability of the sample for further statistical analysis.
A very good morning, doctor. My name is Ying and my metric number is A23A2222. Now I will present the descriptive statistic 3.1 numerical descriptive measures. Descriptive statistics were used to summarize the data for age, BMI, and insurance charge. The results show that the average respondent is 39 years old with a BMI of 30.65. Insurance charge recorded the highest variations, with a mean value of 12,877 ringgit and 88 cents, and a high standard deviations indicating large differences in medical insurance costs among respondents. Overall, age and BMI show moderate variations, while charts are positively scaled and more widely spread. For this page is about the graphical representation of our sample data. Firstly, figure 2 shows the pie chart of gender distribution. Out of 493 selected cases, 59% are female while 49.1% are male. This indicates that the dataset has a balanced distribution between males and females, with females slightly higher. Next, figure 3 presents the smoking status of the individuals. The majority of the cases are non-smokers, which case for 81.3% of the dataset, while only 18.7% are smokers. This shows that non-smokers form a much larger proportion compared to smokers. Moving on to figure 4, the pie chart illustrates the distribution by region. The Southeast region has the highest percentage with 27.8%, followed by Northeast, Northwest, and Southwest. Overall, the distribution across all regions is relatively balanced. Figure 5 shows the age group distributions. Individuals aged 41 and above make up the largest proportion at 46.9%. The remaining cases are distributed among the age groups 21 to 30, 31 to 40, and 10 to 20. This indicates that older individuals represent the largest portions of the dataset. Next, figure 6 presents the histogram of BMI groups. Most individuals fall within the BMI range of 25 to 29.99 and 30 to 34.99. This suggests that many individuals in the dataset are categorized as overweight or obese. Lastly, figure 7 shows the histogram of medical insurance charges. Most individuals have medical insurance charged below 10,000 ringgit, while only a small percentage have very high medical insurance charge above 40,000 ringgit. The distribution is positively skewed because lower charges are more common than higher charges. That's all for the graphical representation sections. Thank you.
In this section, I will explain hypothesis testing and the variables selected for our analysis. Hypothesis testing is a statistical method used to make decisions between two competing hypotheses. The null hypothesis H0 states that there is no significant difference or relationship between variables, while the alternative hypothesis H1 states that a significant difference or relationship exists. The decision is usually based on the p-value and a significance level of 0.05. Hypothesis testing is important because it allows researchers to make evidence-based conclusions without collecting data from an entire population. It helps determine whether observed differences between groups are statistically meaningful or simply due to chance. This approach is widely used in business, economics, healthcare, and social science research. Based on our sample dataset, we identify suitable variables for both independent sample t-test and analysis of variance, or we call ANOVA. For the t-test, we selected smoking status as the grouping variable and life insurance charges as the test variable, because smoking status has two categories, which is smoker and non-smoker. For ANOVA, we selected region as the grouping variable and life insurance charges as the dependent variable because the region variable has four categories, which is northeast, northwest, southeast, and southwest. The t-test allows us to examine whether mean insurance charges differ between smoker and non-smoker, while ANOVA allows us to determine whether mean insurance charges differ across the four regions.
Hi, Doctor. My name is Tanjasha and my metric number is A23A1F53. I will now present section 4.2, which is the independent sample t-test. The purpose of this analysis is to determine whether there is a significant difference in life insurance charges between smokers and non-smokers. In this study, the independence variable is charges measured in Malaysian ringgit, while the independent variable is smoker status, which consists of two groups, smokers and non-smokers. Therefore, the independent sample t-test is appropriate because it is used to compare the mean values between two independent groups. The null hypothesis states that there is no significant difference in mean life insurance charges between smokers and non-smokers. The alternative hypothesis states that there is a significant difference in mean life insurance charges between smokers and non-smokers. The histogram shown on the right illustrated the distribution of life insurance charges for smokers and non-smokers. Based on the SPSS output, the average yearly life insurance charge for non-smokers is 8,585 ringgit and 9.9, while the average charges for smokers is 31,584 ringgit and 95 cent. This indicates a mean difference of 22,998 ringgit and 96 cents, showing that smokers pay sustainability higher insurance charges than non-smokers. The independent sample t-test produced a p-value of less than 0.001. Since the p-value is smaller than the significance level of 0.05, the null hypothesis is rejected and the alternative hypothesis is accepted.
My name is Choi. Number metric is A23A1607. Now I will present 4.3 using analysis of variance. One way ANOVA was used to determine whether insurance charges differ among policyholders living in four different regions. The independent variable is regions, while the dependent variable is life insurance charges. Next, based on the descriptive statistics, the average insurance charges are very similar across all four regions. The Southwest region has the highest mean charge of 12,973.06 ringgit, while the Northwest region has the lowest mean charge of 12,645.78 ringgit. The small difference suggests that regions may not strongly influence insurance charges. Before conducting ANOVA, event test was performed and produced a significance value of 0.588, indicating that the assumption of equivalence was satisfied. The ANOVA test produced an F-value of 0.021 and a p-value of 0.996. Since the p-value is greater than 0.05, the null hypothesis is not rejected. Therefore, there is no statistically significant difference in the life insurance charge amount of all regions. The effect size analysis show an eta square value of 0.000, indicating that regions has a negligible effect on insurance charge. The JINGTONG has also found that all pairwise comparisons were not statistically significant, and all four regions belong to the same homogeneous subset. Therefore, it can be concluded that there is no significant difference in life insurance charges among the four regions. That's all for me. Thank you.
In conclusion, this study applies statistical data analysis to examine the characteristics and the relationships within the insurance dataset. Descriptive statistics were used to analyze the distribution of age, BMI, and life insurance charges, while graphical representations help to summarize the characteristics of the respondents. For the sampling process, simple random sampling was conducted using SPSS. A total of 493 cases were randomly selected from the first 598 observations. This ensured that each observation had an equal probability of being selected, and this helped to reduce the selection bias, providing a reliable sample for analysis. Through the descriptive analysis, we also obtained useful information about the distribution of age, BMI, and life insurance charges. Pie charts and histograms also provided a clearer visualization of respondent characteristics, and it helped us better understand the dataset. For inferential statistics, an independent sample t-test and one-way ANOVA were conducted. The t-test indicated a statistically significant difference in insurance costs between smokers and non-smokers, showing that smoking status has a considerable impact on insurance costs. The ANOVA results showed no significant difference in insurance costs among the four regions, and this means that the region does not significantly influence insurance costs in this dataset. Overall, smoking status has a greater impact on insurance costs than region. The findings demonstrate how statistical analysis can be used to summarize data, identify patterns, draw meaningful conclusions, and support evidence-based decision-making. That's all from us. Thank you.